All right, we're going to work through the word problem that I assigned you last week. Let me just read it through. So biologists have found that the number of chirps that a certain species of crickets make per minute is related to temperature, and that relation is almost linear. They tell us that these crickets make 124 chirps per minute when it's 68 degrees, and when it's 80 degrees, they make 172 chirps per minute. So let's just write that down. When it's 68 degrees out, they make 124 chirps per minute. And when it's 80 degrees out, they make 172 chirps per minute. And then the book asks you to find an equation that relates the temperature to chirps per minute. So when they tell you that chirps per minute and temperature are related, that the relation is almost linear, linear means that your equation will be for a straight line. I think I told you last time what a linear relation looked like. So linear relations look like ax plus by equals c, and that's just another way to represent a straight line. We often like to represent straight lines in a different way that makes the graph a little bit more clear. We talked through two ways last class. One of them was with the y-intercept, so where we have the slope, and then the y-intercept. So this guy is telling you the y-intercept in your graph, so where you intersect the y-axis, and that m is going to usually stand for slope. Okay, so what's y and what's x here? I'm going to let y be my chirps per minute. And x is going to be temperature. Now that makes sense because this guy is the independent variable here. This is the dependent variable. Just reminding you of some things you should have seen in high school. So what this means is that as x changes, as the temperature changes, that's what forces the change in chirps. So it's not that chirps are forcing the temperature to change. That's kind of silly. It's saying that, well, when crickets are cold, they don't like to chirp, but if it's nice and warm out, then they are more likely to chirp. So the temperature is what's forcing something to happen here. So that's what's our independent variable. It's the guy that makes the y do something else. So now that we've got our variables named, let me just remind you of one other way we write a straight line. I gave this to you last time. It's point slope. So we still have slope here, but then we also have a point on our line. X naught, y naught is showing up in this equation, and I'm going to use this for the solution to the problem they're asking me about. So let's get a nice fresh page. So to use that point slope, let me rewrite it here. I need a point on my graph, and I need the slope. So actually they gave me 2 points in the problem, and I'll just write down one. They told me that when it's 68 degrees, so that's like my x-coordinate, there are 124 chirps per minute. That was my y-coordinate. So that's going to be my x naught, y naught here. Now the slope is going to be change in y over change in x. Just to remind you, the way we compute that is we compute the difference between two y values on the line over the difference between two x values on the line. So another point on my line that they gave me was this: at 80 degrees, there are 172 chirps. So if we plug that in here, let's put the bigger one first. so everything comes out positive. I'll have 172, that'll be my y1, minus the y0, 124, over my x is 80, and the other x is 68. And if you simplify this correctly, you should get 4. So that's my slope, and now if I plug into the point slope form here, I know I need to put in a 4 for my m, and then I'm going to use the 68, 124 guy. So y minus y naught is 124, equals m is 4. Okay, so m times x minus x naught was going to be 68 here. Okay, so that's going to be my answer, and that's totally right, and there are many right answers. This is just one way to get an equation for this straight line.